Hey scholars, it's Miss Tarleton with another math lesson for today. In today's math lesson, we're going to talk all about place value. We've been talking through place value, learning our hundreds place, our thousands place, our 100,000s place, and we've gone up to the 1 millions place. But today, we're going to go all the way up to the 100 millions place. So I went ahead and I wrote a number up on the board, and we're going to go ahead and point and say the place of each number, what place it holds in the whole number. So when I point all the way here at the right, the smallest place is the ones. Next we have tens, hundreds, comma, thousands, 10,000s, 100,000s, comma, millions, 10 millions, 100 millions. One more time, starting at our ones place. Ones, tens, hundreds, comma, thousands, 10,000s, 100,000s, comma, millions, 10 millions, 100 millions. All right, good job, scholars. So I want to help use some common items you have around your house to help you realize how big a million of something is. And so first, before I do that, let's take a look at this green number here on the board. Next to me, it's got a bunch of nines. You're probably already starting to figure out what this number is. And it goes 6 places in, so ones, tens, hundreds, comma, thousands, 10,000s, all the way out to the 100,000s place. Let's see if we can sync up our brain powers and figure this number out. This is 999,999. It's a really big number. One more time, 999,999. Well, that is a lot. It's a really big number. If I added 1 to that number, could you tell me what number that would be? If you said a million, you are right. 1 million is the next biggest number in the sequence. 1 million. And so you're probably thinking, well, 1 million's a big number. It is a big number. And to help us illustrate that, I have with me some salt. Some salt. You put it on your French fries, use it to season your food. Salt is really, really small. In fact, it's so small, I don't even think I could show you on camera. Give me a little grain of salt. Some salt in my hand. Bam! Salt. And I have a handy dandy measuring cup. A measuring cup. So this is a 2-cup measure. That's 1 cup. And that's half a cup. So you see I have a half a cup of salt here. In my measuring cup, there are about 1 million grains. 1 million grains of salt. This is a million. So if this is a million, I want you to think 100 times as big as this. So what do we think 100 million would be? 100 million. Okay, so salt is really small. I already salted the floor once. I'm not going to do that again. And if this half cup measure is 1 million, I want you to put your thinking caps on with me. I didn't buy that much salt to fill these containers, but I have a couple containers to help you visualize 100 million grains of salt. So this is one of my favorite lemonade jugs. It's a 2-gallon good boy. I usually fill it with lemonade or iced tea on a nice hot day. This is 2 gallons. I also have a handy dandy 2-gallon utility bucket here. 2 gallons, 2 gallons, 2 plus 2 makes 4. Of course, I didn't have a 3-gallon bucket for this illustration, but 100 million grains of salt. 100 million is about 3 gallons. So that would be 1.5 of these buckets full of salt, or 1.5 of these jugs full of salt. That would be 100 million. So 100 million is so big that it makes this pesky 1 million look really, really, really small. And so place value, 100 million is a big number. I have it right here in green with the arrows going around it. 100 million is a really big concept. So that is our lesson on place value. One more time, let's point and say our place values. Let me put the bucket down. Ones, tens, hundreds, comma, thousands, 10,000s, 100,000s, comma, millions, 10 millions, 100 millions. Awesome. Thank you so much for tuning in. And if you're sticking with me to do a few problems, let me just get my board set up and we'll be right there. All right, so we've been talking about place values up to the 100 millions place, and I went ahead and I put a few numbers on the board. They don't have commas, so we need to add the commas, and then what we're going to do is we're going to write the value of the circled digit. So we know the place name. This place is the ones place, and there's a 9 in it, so I have 9 ones. The place value would be 9 ones. Here I have an 8 in the tens place, so I would have 8 tens. I'd have 7 hundreds, 6 thousands, 5 10,000s, and so on and so on. So let's go ahead and let's look at this first one together. So we always want to start at the right and count 3 digits in and put our comma. So 1, 2, 3, we put a comma right there between the 3 and the 8. 1, 2, 3, we put a comma right there between the 5 and the 2. 1, 2, 3. All right, so this number, let's see if we can figure out how we would say this number. This number is 600 million, 695,243,817. 695,243,817. And so the digit circled is in the millions place. So the value would be what? You guessed right, 5 millions. So we would go ahead and we would write 5 millions as the value of the circled digit. All right, let's look at the next one. So starting here at the far right, 1, 2, 3, we put a comma between the 1 and the 9. 1, 2, 3, put a comma between the 6 and the 2. And then we have 3 digits there. So let's take a stab at this one. This is 486,271,953. Now I like to, when I'm going along and counting, not just when I teach, but when I actually read these numbers in real life, I like to go ahead and touch the comma to remind myself of where I am in the number. So notice I said 486,271,953. And the circle digit is the 8, and the 8 is in the 10 millions place. So the value, if I have 8 in the 10 millions place, I would have, well, I could say 8 10 millions, but what's 8 times 10? You guessed right, 80. So I actually have 80 millions. And think about it too, the way we read the number, 486 million, 80 millions. All right, let's see if we can do this last one together. We got to place our commas first. 1, 2, 3, put a comma. 1, 2, 3, put a comma. 1, 2, 3. All right, so this number is 257,495,136. What is the value of the circled digit? If you said 200 millions, you are correct. We have 200 millions. So when we write that out, 200 millions. Does anybody remember how many gallons of salt that would be? If 100 million is about 3 gallons, 200 million, 6 gallons of salt. That's a lot of salt. That is a lot of salt. All right, so this is a further reinforcement of our place value concept. We're going to go ahead and get set up for a couple of division problems. If you're staying with me, I'm moving on to number 3. All right, scholars, so I have a couple of division problems on the board. Let's quickly recap our 5 steps of division. We have divide, multiply, subtract, compare, and bring down. So step 1, we divide. We're going to ask ourselves, how many times does 2 go into 1? And we know that 2 does not go into 1, so let's put an x in the quotient. So now we have to look at this number 16. Well, we know our 2 times tables, so we know that 2 times 8 gives me 16. Step 2, multiply. 8 times 2 is 16. Subtract is step 3. Compare, 0 is less than 2. There's nothing to bring down. So to check a division problem, this is a recap on yesterday. What do? That's right, we multiply. So we're going to multiply our quotient of 8 times our divisor of 2. 8 times 2 is 16. It all checks out. Let's go ahead and let's look at the next one. I'm going to grab a green marker just to mix up the colors a little bit. So our 5 steps again, scholars, what are they? divide, multiply, subtract, compare, and bring down. Very good. So we look at 4, and we're dividing 36 by 4. Well, how many times does 4 go into 3? It doesn't. So we'll go ahead and put an X in the quotient. We do know that 4 goes into 36. We know our 4 times tables. So who can blurt out, what is 36 divided by 4? 9. Good job, scholars. Good job. So we're going to put a 9 right there. You might have also learned, and you might prefer this way, of putting a 0 in the place there as opposed to the X. Either way works for me as long as we get that 9 in the correct spot. So 9 times 4 is 36. Step 3, subtract. Step 4, compare. 0 is less than 4. Step 5, we don't have anything to bring down, so we're ready to check. So when we check, we multiply our quotient of 9 times our divisor of 4. And 9 times 4 equals 36. So that was a quick recap on division. If you need to slow it down, rewind it, play it back, you can absolutely do that. And what I'd like to do for the last portion of today's lesson is I want to look at solving for variables. So some of that algebra stuff that we were looking at. So let me just get my board set up for that really quickly, and we will jump right into it. All right, scholars, so we have been talking a lot about solving equations for unknown variables. We're doing some algebra type thinking here. We've got a letter that we don't know what it means, but we're going to go ahead and solve. First step, we want to do what we can absolutely do first. So we know 13 minus 7 equals 6. So we're going to bring the 6 down, bring everything else down as written, so the equal sign, and the G plus 2. Okay, so we have G plus 2 equals 6. Well, we need to get that G by itself. So what we're going to do is we want to do the opposite of adding 2. What's the opposite of adding something? That's right, subtracting it. So we're going to take away 2. And whatever we do to one side of the equation, we have to do it to the other side of the equation, or the equation won't be equal anymore. So our plus 2 and our minus 2, they cancel. I'm left with just a G on this side. G equals, what's 6 minus 2? Well, 6 minus 2 is 4. So it looks like we have an answer. G equals 4. So we need to check this. The way we're going to check it is we're going to plug 4 in for G in the original equation. So I'm going to write the exact original equation, but instead of putting G, I'm going to put 4. 4 plus 2 equals 13 minus 7. So we plugged 4 in for G because we're checking it now. And so we solve both sides. 4 plus 2 equals 6. 13 minus 7 equals 6. It checks out. So G equals 4 is our answer. Good job, scholars. Let's look at the next one. The next one we have here is P minus 2 equals 7 minus 3. P minus 2 equals 7 minus 3. And so again, we want to solve the stuff that we can immediately see the answer to. So we're going to do 7 minus 3. We know 7 minus 3 equals 4. And we bring everything else down just the way it is. So P minus 2 equals 4. And I want to get P by itself, so I have to do the opposite of taking 2 away. So instead of minus 2, I need to add 2 to get the P by itself. So we're going to line that up. And again, to keep the equation equal, whatever I do to one side, I have to do to the other side. So the minus 2 and the plus 2 will cancel, and I'm left with just P equals 4 plus 2 is 6. So P equals 6 is my answer. Well, we want to check this. So we're going to plug 6 in for P in the original equation. So I'm copying the original equation, but instead of writing a P, I'm going to put a 6. So 6 minus 2 equals 7 minus 3. And then we solve. 6 minus 2 is 4. 7 minus 3 is 4. And that checks out. All right, scholars, so thank you so much for hanging out with me on today's lesson. If you have any questions, go ahead and rewind, play things back, or let me know that you have something that you need a little bit more clarification on. Until then, I will see you later. Bye, scholars!